Hello everybody and welcome back. So in this lesson we're going to be doing another example, and we're going to be trying to sort of take some of the stuff we've learned recently and put it into practice. So one of the things that we're going to be focusing on is building a shelf tool, so something that is reusable and then is also built to be reusable. So we need to build the script in a way that doesn't require the user to go in and check the code, but something that is actually a little bit more kind of robust and complete. And also obviously something generic that you would use again instead of something just one-off. And then we're also going to just be using that sorry, we're going to create a parameter as well. So we're going to use our parameter template group kind of modules that we were using, and also the quarks that we learned about the shelf tool. So kind of essentially taking everything we've been talking about lately and doing something useful with it. So what I want to do is I want to create a script which I've actually found pretty useful in the past, which is creating a reference copy of an entire node. Now the Houdini does have an option to do this. So let's say we have transforms on this, and then we want on another node to be able, well, we essentially want a copy of this node, but you don't want to have to, let's say, copy it, and you've got something else over here, like, you know, maybe a box or something, and you want these two to share transforms. So if you maybe scale your scene or something, maybe this grid is your emitter, then the box is your collider. Well, you want them to scale equally, so then you go and link scale over here to scale there. But then you also go, oh well, I'm also going to move this around as well, and so when I move it I want to keep the translate here, and I want to rotate as well, and by the end you're just copying every single parameter, and really what you want to do is say everything that is applied to this should be applied here as well. Okay, so Houdini does give you an option to do this. If you right click and say action and then create reference copy, then this creates a node which is linked 100% entirely to this node. Okay, and so we can go and plug that in, and now everything we do to the one will be done to the other, right? So why would we want to do our own? Well, although this is very useful, there is a little bit of a limitation. It's fine when it's in one geometry node, but now what about when I go and move this, right? So I can go, if I go and maybe cut this and move it into a different geometry node, so maybe I have my box in here, then when I paste this, right, all of these links are broken because they're all relative paths. Okay, so they're all looking up one level for transform one and finding nothing. Okay, also, even if we could convert these to full paths, well, full paths are not really great usually anyway, so we don't want that. We sort of want it to relink, but we want them to be relative. But also, even if the full paths would fix this problem for us, sometimes we want to then be able to very easily relink this to maybe a different transform. So you've got one set of transforms for maybe one scene. You know, we've actually done this several times where, you know, you've actually got a couple of scenes that are so similar. So rather than simulating all three of them differently, you actually have, you know, like maybe like there's a big splash. And so you've got a few cuts where, like, so there's a character like falls into the water. You'd have them falling in with the camera above the water, but then you cut to them under the water as the character splashes in. Now, depending on how it's animated and set up, you sometimes want to link those two and do it in one big sim, which makes sense. Okay, especially if the animation is continuous, then you might as well sim it in one continuous thing. But sometimes, because of the angle of the camera, the way it's cut, the character actually sort of teleports. They technically have the same continuous animation, but if you had to load the two animations in, they don't line up. The character has been moved a little bit off to the left or whatever, depending on the composition for the camera. So what you want to do is then have a different set of transforms for your collider and stuff. So you essentially, when you switch to the other shot, it's like you correct for that offset. So now you want to switch backwards and forwards between these two different transforms. You know, maybe the one is rotated or whatever. So now you've got this one, and you want to easily be able to switch a reference between them. Now you have to create two over here. You have to create a switch. It's a real pain. So what we're going to do is do something a little bit smarter, and we're going to create a script that lets us create a copy, but it is a copy relative to one single parameter that we're going to create. So I've already got the script created on my shelf tool so that I can show you what it does before we actually create it. So let me show you what this does. So if we click this with a node selected, it creates a copy. The copy is named exactly the same, but with ref copy appended to the end. It has a different color. Chose a sort of a color that you don't often see on nodes, just so that it stood out. And you'll see that every node in here, every parameter, is a reference to the parameter, corresponding parameter on here. And you'll see it does take the right value, but they are relative to this reference source node. And it has created an additional parameter on the top here, which is a reference to that node, right? And so if we go and cut this and move it to our new scene, like our new geometry node, and plug it in over here, you'll see that it still links because it's linked here. And this is a full path. Now, if we wanted to convert this to a relative path, we could. And it's probably better to have it relative. But then, sure, if we do go and copy this, and then maybe on a deeper level or something, we go and have something else inside of here, maybe a tube, and we've got this over here. Well, then this is going to break because we've got a relative reference. But this relative reference can easily be fixed because it's one parameter. We don't have to go through every single parameter and relink it. We just go, okay, we'll just take this up another level, or just go and navigate this to find that node again. And we can easily relink. Plus, if we wanted to, let's say we've got, like I said, two different set of transforms. So we maybe move this a little bit like that, or whatever. So we've got a separate set of transforms here. Now we just go on here and we can switch to transform 2, and it links every single parameter to that. Okay, so, and this is pretty robust. It works across anything. It's not just for transforms. It's any node, like literally any node. We can click the box and create a reference copy of the box, and then it's got all the exact same parameters, right? So, in fact, technically, if you linked it, you could, for example, you could create a reference copy box and have this box linked to the transform. Now, that wouldn't work with most of the parameters, because there would be a whole bunch of parameters that it has no idea. You know, for example, size, I think, is size, whereas on here there is no size, there is only S and scale. But something like center, which is TX, TY, TZ, and rotate, RX, RY, RZ, will actually find the corresponding parameter here, because it's just looking for that name. So it actually finds a few of the parameters, which is kind of interesting. Obviously, it's going to throw up errors with certain things, but we could get around that. We could even build the script where it's a little bit softer. So if it doesn't find the parameters, it just doesn't care. We also have an HScript mode. If I control click on that, it creates the copy through HScript, which I think will be a little bit softer. Yeah, it'll warn that it can't find certain things, but it won't actually error. So the HScript way might be the way to go if you want to link it to a node that is not identical. Okay. All right. So let's create this now. Okay. So we know exactly what it's going to do, and as I've said before, if you want to challenge yourself, please stop at this point, stop the video, and go ahead and see how far you can get, and then obviously come back, follow along, and then when you reach a point where you think, okay, now I'm understanding, then pause again, try. You know, if you challenge yourself to do that, you're going to learn a lot quicker. Okay, so what we're going to do is we're going to create the script in our Python source editor first. Okay, yeah, sure, we will later on create a shelf tool for it, and we will change things depending on the you know, the way that shelf tools work. But most of the time, I develop scripts, at least the first pass of it, I develop in the Python source editor. Even later on, when we start using external scripts like with PyCharm and stuff, and storing stuff separately, you normally want to be able to immediately test things. So I always build in here first and then take it over to PyCharm and link it up to the shelf button or the HDA or whatever separately. Okay. Once it's functioning, then sure, you make quick little tweaks just directly wherever the script is. But your first pass, it's very easy to think in the Python source editor, because you can literally like drag stuff in or just disable, click apply, and stuff actually happens. Okay. Right. So one of the things we want to do is we want to be able to apply this script to any nodes that we have selected. So in the end, I am going to encapsulate this whole thing in a loop, which is just going to loop through all the selected nodes. That's just sort of an extra thing. And normally with these types of shelf tools that react to nodes, you almost always put it inside of a loop of for n in who.selected nodes. Because if your user selects multiple nodes, they're obviously doing it on purpose and clicking the button. It would be a very bad tool if it didn't kind of just go, okay, well, no, you have to select one at a time and click this and apply the whole script one at a time. I mean, you know, we wouldn't like a tool like that, so why should we design one that works that way for someone else? Okay, so we are going to encapsulate that in a loop, but for now, I'm just going to assume that my node is going to be this one node. Actually, sorry, not this node. Let's create a transform. It's just an easier node to work with. And it's also got a few specific examples on here that I want to refer to. So if you can, just do it specifically on a transform node so that you'll have the same challenges as we are going to face here, because this node has a couple of little hidden tricks in it. Now, I'm going to call this n because later when we do our loop, I'm going to say for n in who.selected nodes. So then we don't have to replace anything else in our script, just instead of a static link to, or a static reference to this node as n, I'm going to do it, just swap it for the loop. Okay. So what I want to do is quite obviously just create a copy of this node. So we want to grab the type of this node and then create a new node that has that same type, has the same name but with an additional appendage, right? And then also just maybe move it a little bit off to the side, give it a different color. And I mean, where we create that node should be in our same parent. So it should be on the same level as ourself. Okay. So those are a few things that we should know how to do by now. So I'm going to call the new node new n. Okay. It's just easy to understand. Now, if I want to create a node on the same level, then what we do is we do n.parent to refer to the parent of the node. And now we create a node inside of that. So n.parent.create node. What type do we want? Well, we don't know specifically, because I don't want to just go here and give it X form, because it could be any node. This node could be swapped out for anything. So we need to implicitly go and grab the type of the node. So if you remember, that is n.type.name, because n.type is going to refer to, so if I pull this in over here and just type .type, it is a Python object that refers to the type. Okay. If we do n.type.name, then it gives us an actual string that relates to the type. And when we create a node, what it wants here is a string reference to the type, not just the actual Python object. So n.type.name. And then our second argument that we're going to feed it for create node is our name, which you remember is an optional argument, but we do want to give it a name. So we want to call this exactly the same as its current name, but we want to append the word ref copy or whatever you want. So I'm going to just use format here. So I'm going to replace it with its own name, but then underscore ref copy. And if I say now dot format, and then we want to give it its name, so it's n.name. Sorry, got a frog in my throat. All right, so there we are. So this should create a copy of our node. So let's try that. If I click apply, you'll see it does. Over here, it creates a node, and it's called transform1 ref copy, and it's a transform node. Okay, if we swapped n for our grid, and then click apply, it's going to create a new grid. All right, so that's all fine and well. Next thing we want to do is set its position. Now, obviously here it did put it off to the side, but you see when we did it to the grid, it also put it on top of that. So this is kind of just a default location. In fact, let's test, but this node is probably sitting at 0, 0. So this just happens to be our origin. It would be bad if we just assumed that that's where the user would be working, because what if they drag their nodes off to the side over here? Okay, now when they create a node, let me just drag this a bit smaller. When we create it, it creates it all the way over here. So we can't just make any assumptions. We need to reposition this node. So we're going to say new n dot set position. All right, and we just want to set it to the same position as the node, our current node, the parent that it came from. So we'll just say n dot position and then do new n dot move. Okay, this isn't, just like I said before, my preferred method of moving stuff. So let's move it 1 to the right, so 1 unit off to the right, and then 1 unit down. Okay, so 1 and -1, but you really can move it wherever you want. To me, when I create new nodes, sort of off and down or to the top right or whatever is preferable. You could also, if you wanted to, instead of just doing this basic one, because this one does have problems with it. I mean, what if we had other nodes over here as well? Okay, like if this was a very busy scene, when I run this, it's going to create it in a really bad place. But I do want it to kind of be near the node that it was copied from in this case. But if you wanted to, you could go back to our bounds script and actually have it appear to that sort of top right or bottom right or whatever of all the nodes that already exist. But anyway, I'm going to do it this way, and in fact I'm reducing it to 0.5 so that it's a little bit closer, just so we have like a very definite, okay, you know, this is a copy of this, we've just created it now. Because also if we do go and grab, let's say, a whole bunch of nodes, so if we grab a whole selection of them and click apply, you want each one to have its new copy created just next to it, so we can go and reposition that. Because the assumption is we're going to create a copy and then go and manually attach that node wherever we want. Okay, and that's also why I'm not going to have it automatically plugged in, because we're not assuming that they want it plugged into the same root node. We just want a copy of the actual node, and we're going to take this node and go and apply it somewhere else. We might even cut it out of this geometry node and go place it in a different one. Okay. So we've set the position. Let's also set the color. So we're just going to go new n dot set color. Now remember, this must take a who.color type, and now we can feed it our RGB values. Now what color do we want? Well, we can go and, in fact, I'm going to disable this, click apply, so we've got one to use, and then I'm going to click on here. Now, you can select from this palette, or you can just feed it any sort of RGB values, but I just went and selected this color on over here on the right. So I believe if you right click or middle click or something, it does, maybe it's because I got this pop-up up, but there are ways to, oh, there we go. You can, if you do right click, then you can say edit color, and then you can at least see what the RGB values were. My preferred method of that though is just make the node that color, and we just drag this in and we go dot color. Okay, like really easy. So we're going to use Python to grab the values. Now you don't have to match this value exactly. I mean, you know, it is just color. maybe if you're going to use color later and refer to it, but that's probably a bad method. So I just go and give it kind of vaguely the same sort of values, 0.38. I'll give it 0. Let's just round that to 0.4 and then 0.5. Okay. I mean, really, you could just fill in whatever random values you want here. Okay. So now when we click apply, it creates a copy there, ref copy, same type, different color, same name with an appendage, almost same position, but just slightly offset. Okay. So that's a good start. Now, what else do we want to do with this? Well, obviously we want to link all the parameters, but the parameters need to be linked with a reference to that parameter that we need to create. Just a general global parameter of which node is the target. So we're going to, when we create this new node, we're going to need to create a new parameter. Now the node that we are placing down could be a copy of anything. This is a standard Houdini node. It could just be a blank geo node or a subnet, or it could be a published HDA. So we do not want to alter the definition of a node to add a parameter. That is absolutely not what we want to do. Okay, so we want to create only a spare parameter, because then if we're dropping down an HDA, all of its parameters are set by the definition, but then we're just adding an additional node, an additional parameter. And if they drop down a new HDA, a new copy of that same HDA, it would not have that parameter reference. Right. So we're going to be doing this at a spare parameter level, which means we don't need to do the who dot node dot type dot definition, that whole thing. Instead, we just are going to refer to the Palm template group on the node. Right. So, and if you're still confused about this section, please go back and watch that lesson. It's probably the most useful thing you will have learned so far, is that parameter template group thing. So, okay, so let's create our new parameter. Now, in order to do this, we need to create a reference to our Palm template group. And in this case, it's the easy one. So we're just going to be doing dot Palm template group. But remember, we're wanting to do this on the new node, not on n. So we're actually now using new n dot, and then it's Palm template group, right? And let's make no assumptions. Let's actually check that this is working. So when we do this, it prints Palm template group. Okay, so we do have that correct reference. Now, what we want to do is we're going to be creating a new node, a new parameter, right? Now, what type is that parameter? Well, let's go and have a look. If I go and manually create this node, right? And then I'm going to go to edit parameter interface, which essentially this is kind of what we're doing through the code, is going to parameter interface. And what node would I drag in? Okay, well, I want a reference to a node. Okay, I want it to literally point to a node, and if I click the little button next to it, I want it to take me to a list of nodes in the scene. So we can do operator path. Okay, now if we drag this operator path in, okay, you'll see it's this type operator path, and then if we just accept, okay, if I click this, it takes us to a list of nodes. Okay, so this is exactly what we're wanting, right? But what type is this? If we go now to help contents, right, and just give it a second, because it always takes a while to wake up. So remember, we had our who.palm template class, which had a bunch of sub node types inside of it, right? Subclasses. You're going to find that the operator, well, what was this called? Operator path type does not exist. Okay, doesn't exist in this list. So what is it? It's obviously got a different icon, but really it is a type that, it's a different type. Now in here it's just one of these, but we can find out what this is by just referring to it in here. Okay, so we're going to pull this in, and I'm actually going to store it. I'm going to say p equals, just in case we need to refer to it again. Okay, so p is the reference to that parameter. Now we go, there is no p dot type. Okay, if you remember that from when we did parameters, it's strange that, you know, that there is no p dot type, but that's because parameters are defined by their PALM template. They do not have a type in and of themselves. So you need to go p dot PALM template. Okay, and now we can see what type this is, and it is a who.string PALM template. Right, now that does make sense, because even though this has additional kind of operations to it, like it has a sub menu over here and whatever, but really what is it that we're entering here? Even if we navigate to a node and we say, okay, yeah, that node over there, what is this? This is a string. Okay, so it makes sense that this is a string PALM template, but it just has certain additions to it. Okay, so it has some additional tags attached to it, and it'll also be string type node reference, right? So there are certain essentially defining features to the string PALM template, which allows us to choose a difference between a node reference or, for example, maybe a file reference. So like when we have a file node over here, and this parameter over here, where we click here and it navigates on disk, okay, what is that type? If we do that dot PALM template, you're going to see that it's also a who.string PALM template type, but its string type is file reference, right? As well as a whole bunch of other defining arguments. Okay, so it's important to understand what type we're trying to create. Right, so I've got this string PALM class open, so we're going to use this as a way to as a reference while we define what our string does. Okay, so let's create a new string. So I'm going to call this, I'm just going to call it source, because it is the reference source parameter that I'm trying to create. Okay, so I obviously want to store my string PALM template, because remember, we're going to create a parameter, but that parameter is not attached to our group, and technically this group is not even attached to the node yet. So we first create the loose floating group, we create the loose floating parameter, we attach the parameter to the group, then we attach the group to the node. Okay, so that's what we're going to be doing. So who.string PALM template, that's what we're doing, because we're calling the constructor function of this node. Right, so this init function. Okay, so what do we have in here? We've got a name, so let's give it a name. So we're going to call this ref source, right? So because it's a reference source, the source of all the reference for all the parameters. Okay, and then the label, let's make it more understandable, so we're going to call it reference source, because you want your user, when they don't know what that is, to kind of infer what it might be based on the name. But it will also be pretty good for us to give an actual help file, like sort of help string, that allows them to understand, if they hover over it, what this is actually doing, because we're creating a parameter here kind of without their permission, and we're expecting them to understand what it is. Then the number of components, well, we just want one. We don't want a sort of multi string. It's a single value, right? Now, default value, we don't really care. It should be empty by default, but also we don't actually care too much, because we're filling in a value ourselves, and this is a spare parameter, so this will never be created by default. Like, we are filling in the value anyways. We're overriding it. The naming scheme, we're fine to leave it just base 1, right? If you go and have a look at the different naming schemes, you'll see what they are. So middle click on that, and then middle click here on who.palm naming scheme, and you'll see the list of available ones. But yeah, base 1 just is, you know, foo 1, 2, and 3. But the thing is, we don't have multi-palms anyway, so this really doesn't matter to us. So we're just going to leave it at the default. But here, string type. Now this is what we want. And let's have a look at the options. So if I go to string type and then middle click, so we're on string palm type module. These are the options we have available to us. So regular is obviously going to be just a normal string. There's a file reference, which was like on our file, node reference, which is what we want, and then a node reference list, which will be like in your kind of in your ROPs, when your candidate objects, where you're selecting nodes, but if you select a new node, it's adding it into the list instead of expecting there to be specifically only one node referenced. Now that is not what we want. We want this. Okay, so it's just dot node reference like that. So let's go back here and continue. Where were we? Here we are. Okay, so that's the one argument that we want to fill in. So we're going to call it, so it's string type like that. It must be named exactly the same as that keyword. We say equals, and then it's who dot string palm type dot node reference. Okay, so that's our argument there. And then the last one I want to do, I mean, you can go through all of these and have a look, but we don't want a menu or anything. We're not going to specify a file type because we're not looking at files anyway. The only other thing I really want to do here is give a help string, because honestly, our user doesn't know what this parameter is. So let's tell them what it is. Now, because this is already getting really long, and I don't want to keep typing over here, what I'm going to do is I'm just going to say help equals, and then let's give it a variable reference. I'm just going to call it help text. Okay, and then above it, because obviously to reference it here it needs to already exist, let's create another variable where I can store this string, because then we can type whatever we want and then just feed it in here. Splitting it into multiple lines is a lot easier. So I'm just going to give a little explanation. So just something like this is a reference to the source node whose parameters should be referenced by this copy. Okay, that seems explicit enough to just sort of say, okay, this is what that's doing. So if they hover over the parameter, it'll actually tell them what they're referencing. All right. So here we've created our parameter, but we need to attach it to the group. Now, where do we want to insert this, right? Or where do we want to add this? Well, it's got to be right at the top. Okay, like right at the top. Now, appending or add parameter is going to add it at the end. Okay, so we don't want to do that. So the only option available to us is insert. Now we can insert after, or we can insert before. Of course, we want to insert before, but we want to insert before the very first parameter, regardless of what it is, including if that parameter is a folder type or whatever. It doesn't matter. So if, I mean, let me just try and think of a different node that has something. Maybe material does. No. Some things have every parameter contained within a folder, so there are no loose floating parameters. The very first item in the list is an actual folder that contains all the parameters, right? Even in that case, we want to insert our parameter above that, outside of the group, okay, outside of the folder. We essentially don't want to interfere with this node at all. And so what we're going to do is we're going to insert before. But if we use that, remember the sort of indices list, and it would say, if we were, let's say we had that example 202, which was saying that it was in the second folder, well, third folder technically, because it's 012, then inside of the first folder, and then it's item number 2, okay? And if we had to insert before that, it would insert it inside of this, inside of that, but before this. So instead, what we're going to do in this case is if we refer to just 0, that means that it's going to go only to the first folder or the first item, no matter what it is, folder or parm, and just insert before that. It's not going to go any deeper. It's going to stay on the top level, and it doesn't care what that first item is. It's going to insert before that item. Okay. So that's what we're going to be doing here. So we just say, so remember we're inserting it into the group. So we say group dot, and then we insert before, and then we need to give it where we're inserting it. So it's 0, comma. Okay. Remember it has to have the comma, otherwise it doesn't know that this is a list. And then we just feed it the parameter which we have called source. Okay. So group.insert before, then this is our very first index, which will be this group. Okay. So this parameter over here is going to be 0. And then we're just inserting this before that. Okay. But again, if we clicked apply now, this would do absolutely nothing, because we're applying it to this group, which is just floating around. Okay, we've created a copy, a reference copy of the PARM template group from this node. In fact, actually from new node, this one. But we have not attached this to the node. So we need to do that, right? So we just go new n, so the new node dot set PARM template group, and then we're replacing it like I said, like face off, we're replacing it with the entire new group. There is no way to just add parameters in. We have to literally take the entire face, essentially, copy it, change it, and then swap it out. Okay. So new n.set PARM template group, right? So let's try this. We should at this stage be able to create a copy of the node, and then it should have this new section added. Also, by the way, when our scripts start getting longer, you might sometimes want to leave notes for yourself to know what sections you're doing. So here we're kind of saying we're creating the copy. Okay. Here though, we're creating the source PARM or something like that. Okay, and you can just leave yourself little notes just with these hashtags, so that it kind of is a comment. Okay. And this above bit, obviously, we're going to be swapping out later. So you can even leave a note for yourself. Now that you normally write it in the line, you will sort of put, I think you have to put a double space and then this, and then we'll say swap out for loop. So that's a little note to ourselves for later. Okay, but then this is almost a heading that I use to separate what I'm doing. Okay, so now let's click apply and see what happens. So luckily there were no errors. I mean, obviously there's an error on that, but that's because it just wants a source. But we've created a new node, and look over here, we have a reference source. If we hover over it, it gives us a help hint, and it is the right type. If we click there, it navigates our scene and lets us do that. Okay. Now what I just did there of referring to the actual node is what we want, because we don't want our user to have to do that for us. We know where it should be coming from. Yeah, sure, they can alter this later, but we won't know which node it should reference. And that node is n. It's the node that we were copying in the first place. So we might as well just go to our new parameter now, okay, and set its value. Now, when we create nodes, we get a reference to that node, but when we create parameters, we do not, because what we created over here was the actual PARM template, not the parameter instance itself. So we have to go and fetch that. So we say new n dot, and then we go to the PARM. Now we know what it's called though, so it's called ref source. Okay, and then on that PARM we're going to set. And we're just going to set it to be equal to n.path. Okay, so the path to our node. So now if we do this, when we click apply, this section is already filled in for us. Okay. All right, so that's pretty much everything that we need to do up to that sort of that section, because we now have a new node and it's ready to kind of start linking these parameters. Okay, that's the only thing left, is we want to go one parameter at a time. We want to take this, we're going to copy this, paste it. In fact, I'm going to do it on scale because it's just a single parameter. So I'm going to test it on one of the most easy ones first. So paste relative reference, but we want to alter this. Okay. So we'll start with the HScript version. We'll do a Python one later. You don't necessarily need to include both, but I just want to show you guys how to do the references through Python and through HScript. Okay. So what we want to do though is instead of referring to transform one through like this, we want to refer to this string and swap this string out for this over here and then attach scale at the end. Okay, so let's alter this so that it looks right. Okay, in fact, let's come over here. So what we would do is I like to sort of think it through like this. So if I still went and just separated this into two different strings, but with a plus, okay, so we separate it like that and click apply, you'll see that it still works. Okay, it's still linked. So that works perfectly fine. And now because I know, okay, that is working fine, I can now swap this string for just a string reference. Okay, so we can just use ch, but remember, because we're referring to a string, it's going to be chs. Okay, so chs, channel string, and then we're going to refer to this node because we want its string. Okay, because if I copy this string and insert it here, but inside of quotes, then this will work, which means that by referring to that node as a channel and essentially telling it to evaluate it, we are going to grab that value. Okay, so what is that called? Well, it is called ref source. Right, so now if I do that, it works perfectly fine. Okay, now if I copy this and put it over here in shear, right, that's not referring to the shear value, that's still referring to our scale, and that's because we have this statically linked in here with this name. Okay, so each parameter needs to refer to its own name, right? But unfortunately, that is a lot harder than it sounds. We can't just tell each parameter to look at its self. Okay, so what we need to do, I mean, we're doing this through Python, so looping through each node and checking what its name is not a problem. So here it's called shear1. Okay, and now if we look, those two are different, but then if we move that, then we get those two values. Okay, so that's essentially what we want to do. Is all of this is fine except for this over here needs to be replaced. We still need the slash, but we're going to replace this bit with another string. Okay, so we're going to do that through code. Okay, so let's build that section first. Right. Now, there are going to be a few exceptions that we're going to talk about, but for now, let's just go and specifically let's create a little heading over here for ourselves, and we're going to say we're going to call this link parms or something, so we know that that's what we're busy doing. And we're going to go p dot, right? Oh no, hang on. We're gonna need a reference to the parameter, right? So we're going to loop through all the parameters on this node first, and then call each one p, right? But let's just do it specifically with scale first, just to make sure that that is working. Okay, because you need to be very careful. If we do this wrong, slightly wrong, even while we're working, and I mean it's natural that while you're writing scripts, you're going to make mistakes, small little syntax errors, or you forget to refer to the type, or build a little, oh, try this, try except, or if else, or whatever. There's no way you're going to type it and get it right the first time. And sometimes that can cause a lot of crashes. When I was building this, I had a lot of crashes because, as you're experimenting and fiddling, if it can't create it properly, it just seems to have a huge problem. Okay. Now that's not great. Obviously, side effects would try and build Houdini to not have those kind of crashes and rather just report an error. But they're not perfect, and sometimes they're going to miss a few things. So in this case, I found a lot of crashes. So be very careful what you do here. This is why we're going to refer to one parameter at a time first. So let's just refer to this parameter as, so we're going to refer to scale, but in fact, instead of doing it through this, we know we want to refer to scale, but on our new parm. So we on our new node, so new n.parm scale. Okay, so we're just going to refer to that one, but we're going to swap that again for a loop. Okay, so swap for loop later on. Right, so now on P, we're going to do some things. Okay, so basically, okay, let me just try and think how to explain this. So we know that this is a safe bet. Okay, scale, uniform scale here is a float, so we know that this is working. But there are some aspects where this expression will not work. So when we come here to group, right, this is not going to work. Okay, what we need in here is a channel string reference. Okay, obviously it also needs to be linked like this. Sorry, it needs to be an actual expression, right? And then if we link like that, get rid of, hang on, sorry, we get rid of these slashes. Okay, that technically should work now, right? But obviously we don't want to reference scale, we want to reference group. Okay, so if I swap this for the word group, right? So that's going to refer to the group, and then if I type something in here, then it will load it in there. But you see, if I had ch, then it will not load it properly. So this is one of the sort of challenges we have here with HScript, is that we do have to specifically define the difference between channel strings and channels. Okay, so we know that scale is a normal channel reference, but we cannot guarantee that all nodes are going to be like that. So first we're going to build it to work on scale, but then we need to keep in mind that we're going to need to build in a sort of an if, where it needs to check whether it is a string or not. Okay, we do not have the same limitation on Python, because Python is at least very good at typecasting. Okay, so we're now on P. We're going to say, okay, so we need to set the expression. We already know what our expression should be. So we're going to say p.set expression. Okay, then we're going to give it the actual expression as a string. Now in here I've used a combination of single and double quotes. That's obviously not a great idea. I need to stick to one or the other so that I can encapsulate it correctly. So I'm just going to swap. You can swap either these for singles and then encapsulate the whole thing in double quotes, or you could do it the other way around. If these were doubles and these were singles, that would still work. But then these would also have to be doubles. Okay, so everything on the same level needs to have the same type of quotes. Right, so we're going to set it to be equal to that, and then the language we can actually leave out, because the default is the who.expr language is set to HScript by default. So this will work, and that's fine, but obviously as we loop through multiple parameters, scale is too explicit. We need to swap this out for something, right? So we're going to use formatting, string formatting, to swap that section for something, which what we want to swap it for is p.name. Okay, because we have a reference to our parameter now as we loop through. And so by going p.name, we're essentially going, right, you know, I'll loop through this, give me its name and insert it here. Then on the next parameter, we do it, and so on. So like here for shear1, its p.name would be shear1, and so we swap that in every time, including here with group. Okay, so that's how we're going to go and set these. Now let's go and delete that, and I'm going to create a new node. So when I click over here, you'll see it has worked on scale. Okay, but if we start looping through these nodes now, we're going to hit string parameters as well. And so we know that we need to sort of be able to handle that, right? What I'm going to do here, I'm just going to build a quick little list. I'm just going to call it temp list. And I'm going to build a little list of parameters for us to loop over. I'm being very cautious here, you'll notice, because the thing is, if we just loop through all the parameters and apply this right now, it will crash. Okay. I mean, obviously you're lucky if maybe it doesn't, but really it probably almost guaranteed is going to crash. And I'll explain why just now. But I'm going to just grab a reference to my scale parameter, my group parameter, and maybe shear. But I want to specifically refer to shear 1 because we're going to be looping through parms, not parm tuples. So all my references need to be who.parm, parm, parm. And so it's shear 1, not shear, just shear, okay? Because that's the parm tuple. So I've got this mini list. And instead of doing p equals here, I'm going to swap it for the loop now. But instead of going for p in new n.parms and looping through all the parms, I'm going to just loop through my temp list. Okay, so the parm is still referred to as p, but it's just a controlled mini list instead of all parms. Okay, and let me just copy this, and I'm going to save just in case. So just be very careful, guys. Okay, so if I apply, it creates this node and it does it on all three. Now it works for shear and for scale, but it does not work for group because we need to insert that S. Once we do, it then works fine. So we need to essentially swap this section with CH or CHS depending on something, depending on whether this value is a string or not. Okay, so how do we check that? Well, remember when we checked here our parm template type, because we don't have parm.type, but we do have parm template type. And if we look at group, if we say .parm template, and we can do parm template, right? Oh, sorry. Oh, hang on, sorry, yeah, that has worked, right? So when we refer to our parm template, right, it goes who.string parm template. But obviously this is a lot of information. How do we extract the type from this? Well, parm templates have an actual function for type. So if we look in this list, and you'll see over here, when you go to type, there is a type. Okay, so what we can do is say parm template dot type, and it refers to that. Okay, and then that result, by the way, let's come over here, and is a who.parm template type module, right? And it'll be one of these. Okay, so what we're essentially wanting to do is compare those two. Take our node, check its parm template dot type, so run this function to grab the type, and then compare that to just a static, is it a who.parm template type dot string, right? That's our way of then checking whether this parameter is a string or not. Okay, and because if we just check our H script, there are only really two options. It's either CH or it's CHS. Okay, there are other things like you can evaluate a ramp, so there's CH ramp and whatever, but those are, that's just a different way of evaluating it. But here there are really just two types, strings and non-strings. Okay, so we're going to say, we're basically going to build a comparison here. So we're going to take P, which is our parameter, and let's check its parm template type. So we're going to say parm template dot type. Now what we want to do is compare this. So check, is it equal to, and then we grab a static reference to this module. Okay, so this property within this module. Okay, so we say who dot parm template type dot and then string, okay, which is exactly the type that would be returned if we ran parm template dot type, refers to this parm template type dot string. And so these both sides should be equal. That's why we use this equals equals for equivalency check. Okay, we cannot use the is statement. That's because this is a property over here, so they are not the same object. They are just equal to one another. So we use equals equals. Okay. So we can check if this, then let's just do something. Let's just say print, well, let's print P, and then we'll print this. Okay, so I'm going to just print a little thing. So now when we click apply, because we're going to loop through our little loop, okay, our little parameters over there, it's created this, it's linked them all, but it has printed a reference to our group parameter and said that this is a string. So you see it has worked because it didn't print all three, it only printed the one. So in this case now, what do we want to do? We want to do something different here. Well, we just want to swap out the CH for CHS. Okay. So there's a couple of ways we could do it, but in this case, I'm just going to do kind of an easy way. I'm just going to say which expression we should use. So I'm going to call it expr, and I'm just going to give it a static value first. So I'm going to say, well, all your expressions should be ch, except for if this check returns true and says that this actually is a string. And then in which case I'm going to say expr equals, and I'm going to just overwrite the value with chs. Okay. And then in here, we're actually going to swap this out for a reference. Now I want this to be 0 because I want this to be in order. So I'm actually going to swap this one for 1. And then in here, we're just going to put expr and then the name. So this is 0, which will get replaced with this. And then this is 1, so it'll be replaced by p.name. Okay, so now let's test that. Click apply, look over here, and we have CHS. And then here we have CH. And it works perfectly fine. Okay, so that's how we're going to do that. But there is a problem. There's a few problems, right? One, which is a big one. This is the one that will cause crashes to occur sometimes, or if it doesn't cause a crash, it is certainly going to cause some big problems. Is if these nodes over here, these parameters, right? If I hover over this, if I maybe click on it and I hover, I think I can. No. All right. Sometimes they do work. I think if you hover over them or whatever. But anyway, these sort of collapsible folders are a bit of a problem because they do come up in our list of parameters when we loop through node.parms. So in fact, let's from pprint import pprint, then we will do the same expression as before, but we're just going to pretty print it. And in fact, we'll do parms. Let's just do parms. That's fine, right? So what is this actually called? Pivot transform, but then it has pivot. Yeah, here we go. So this here, this pivot transform parm group thing. This comes up in our list of parameters, but it's a folder. Now it's strange because when you do a list of .parms, your folders don't normally appear. They do appear when you list your parm templates, because like we've seen before, parm folders still appear as parm templates, but they're their own just type. But with parms, normally your folders do not appear, but these weird collapsible ones do seem to, and that's because they're called folder sets. They're not actually folders. So what we want to do is check, because if we can actually set this parameter to be equal to, and actually give it an expression like this, okay? And it'll be referring to its parent, looking for the value of this folder, because it has a value. It's either 0 or 1, like as in it's expanded or not. Okay, and what happens is when it does a link to it, sometimes it'll crash, or if it doesn't crash, it links, and then this folder is, like, let's say, closed. But because it's linked here, you can't open it. You keep clicking on it and it won't open. It's locked. But it doesn't grab the expanded value from here, so it's not like if you expand it on the parent, then it expands on the child. It just freaking locks itself, which is terrible. So what we need to do is we want to bypass any of these folders, okay? So anything that is a folder or a folder set, those are the two types, folders and folder sets, we want to skip. Okay. You'll also find like if something that counts as a folder set is, let's say if we've got a material, something like this, these where we've got this kind of complex where we can click plus or minus and we can add things or whatever. Unfortunately, our reference copy script is not going to work with things like this. It's just it'll copy it'll link to parameters that already do exist, but it will not allow us to dynamically add parameters, and as we add them, our reference copy will take on those copies. It just doesn't work that way. Okay, it's a little too complicated for it to handle, and that's because of these folder sets. So what we're going to do is we're going to build a check and to check the PALM template type to see if it is a PALM template type folder or folder set, which are two different things. Okay, in fact, let's look at our list of PALM template types. You're going to see there's folder set, and there is also a folder somewhere. Where is the folder? That is strange. This is an incomplete list because folder is definitely a type. Okay, so unfortunately, yeah, that's a bit of a maybe they just typed this and thought I don't know. Anyway, folder set is a type, but folder is also a type. So because we know that we can drag in, we can reference a folder and actually check that it's an actual folder. Like if we do PALM template, it'll return folder. Okay, so those are two types, and what we're going to do is check, is it one of those two? So similar to what we've done here, and if it's one of those two, we're just going to skip it. Okay, because we don't want to link to the folders. So we do exactly the same thing as we've done here. Okay, so we just go if p.palm template type equals, but then we're going to say palm template type dot folder. I mean, you see here, the folder is in the list. It's just not in their help file list, which is a bit strange. And then we also want to check if it's a folder set. So we have to say or. So it's this or that, and then we're just going to give it folder set. Okay. Now you do have to give it the full thing. You can't just say if p.palm template type equals folder or folder set. Okay, we have to include the whole check, the equivalency check again. Okay, it's not like in English where you can say or and you can list a whole bunch of things that refer to just the one base thing. You have to actually do the full comparison or and then another full comparison. Okay, so it's this or that. So if either of those are the types that our parameter is, then we're just going to skip it. Now how do we skip? Because we've got other text over here, other expressions, but we want to break out of the loop at this point and just go to the next item in the list, because we don't want to break the loop entirely, because we want to keep going through all of our parameters. We don't want to, when we hit a folder, suddenly just stop and do nothing else. We just want to move on to the next thing. And I hope you guys remember what that is. It's the word continue. So continue says, skip this, but move on to the next item in the list and do the whole thing again properly. Right. So in this case, it'll now skip those folders. So what I'm going to do is I'm going to save here, just in case, and I'm going to swap out, instead of this list, right, we're going to actually now attempt it on the new n.palms. Okay. Because in this case, now that we fixed that, it shouldn't crash. Okay, everything else should link correctly. There will still be a problem, but this hopefully will not crash. Okay, so let's delete this. It's clearing up, and then let's try this and create. So we click apply. Luckily, no crashes, and then everything here is linked. Okay, but I can actually expand my folders, which is good. That means that our folders have been skipped and do not have expressions attached to them. Okay, so this has all worked properly, but why is everything 0? Why is our scale not working? Why is it broken again? So there's one more problem, and that's the fact that it looped through our reference source parameter here as well. Okay, so only now when I link it, now everything links correctly. Okay, and now we can go and do this and change things in the list, and everything here will match exactly. Okay, but we need to skip our actual parameter that we've created here. Alternatively, we could do this afterwards, so we could maybe go create all the references, then create our parameter, but I don't like that method because the thing is they are referring to this node, and so it just feels better to me to create it first, but then we just need to tell it to skip here. Okay, so the first thing we'll just do is kind of just check, just say if p dot name, so the parameter name is ref source, then also continue. Okay, we could attach this in here as an OR as well, but I don't like to do that. See, these two make sense in OR because we're kind of saying if it's a folder or a folder set, then continue. But I don't like to link unrelated things to one long string of ORs. Okay, it's just much easier here to see where we're continuing if our parameter is ref source, and then as a separate thing we're continuing if it's a folder or a folder set. Okay, and then this should basically work now. This is essentially the code that we're trying to design. Okay, so this works, and then when we click apply, everything is linked to that node. We can redirect this node or change it to relative, and everything works. Okay, so the last thing I want to do here before we then go and attach this to our shelf button is that instead of doing it through HScript, we could do this link through Python. Okay, so I'm going to take this entire section. Okay, we still want to do all of our skipping in the beginning, but this section here where I'm setting it, this is very much HScript, so I'm going to actually say that's HScript. So what we'll do is we'll encapsulate this in a mode. So we'll say if mode, then we do this, else, and then we're going to do something else. So I'm just going to put pass for now. So mode is just going to be an integer, like basically just a Boolean value. So if I'm going to basically say mode equals 1, it's going to do this, and mode equals 0 will do this one. Okay, but what we'll do is we'll swap out mode for our control click. When we actually create it in this parameter over here, in the shelf tool, then if you control click, it will be 1, so it'll run HScript when we control click. When we normal click it, it will run this one. Okay, but for here I'm just going to statically link it. So with mode set to 1, it should still do exactly the same thing that we had before. If I click apply, it should create this, and it's all linked through HScript. But we're just going to now swap mode to be equal to 0, and then we're going to swap this section for a Python way of referencing this. Now in Python we can do this all in one line. So what we want to do, because Python doesn't care if it's a string or not, it just evaluates the parameter. Okay, so we can refer to our parameter, and then we're going to set expression. Okay, but we're going to be setting it, so it's exactly the same thing here. We're setting an expression, but what expression do we want to set? Okay, well let me create a node over here, a similar node, and let's refer to this node, the scale, but using Python. Okay, so I'm going to alt click, turn this into a keyframe. I'm going to set the expression language to Python. Then I'm going to come in here and edit it. And what we want to do is we want to look at our own node. In fact, hang on. Let me just go back and create a reference copy of this node first. Okay, so let's bypass all of this and say pass, just so that when we create our reference copy, we have this reference source parameter, because we need that. That's what we're going to be referring to. Okay, so again on here, I'm going to alt click, turn this into a keyframe, make it Python, edit. Okay, so I want to refer to my own parameter here. Use this string, so evaluate it, take that string as the path to a node, go to that node, go to a certain parameter, a parameter whose parm name is equal to my own parm name, and evaluate that value. Okay. So we say who.pwd refers to myself. Okay, so this node. And then if we go .parm ref source, so that refers to this parameter. Okay, but I want to evaluate it, so let's do the shortcut and just say eval parm instead of just parm.eval. Okay, so if I clicked apply, this essentially is just grabbing this string value. Now we want to use that string value as a reference to a node. Remember, if you go who.node and then you give a path to a node, it refers to that node. So what we're doing is who.node, and then we're feeding it a string, which is a path to a node. Okay, so that's exactly what we're doing. So now we have a node reference. But we want to refer to a parameter on that node. Okay, so we say .eval parm, because we want to refer to the parameter, but of course we want to evaluate it because we want its value to be our value. Okay, and so when we return that value, it will print it in here. It will apply it to our own parameter. So we say eval parm, but what is the parameter name? Well, the parameter name is scale in this case, because that's what parameter we're using. Okay, so when I click apply now, you'll see that this works. Okay. Obviously it's complaining about not enough sources specified, but here we have a reference and this works perfectly fine. The problem is it's exactly the same thing before. We need to swap scale for ourself. Now there is a who.pwd, but there is no equivalent for parameters. Okay, not that I know of. So this parameter seems to be unaware of its own name for some reason. Mostly because I think, this is a parameter which is an instance of a parm template. And so the parm template knows its name, but the parm seems to not. But we're just going to do the same thing we did with the H script. As we loop through, we will just swap this statically for an actual parm string. Okay. So in here, instead of pass, we're just going to give it this expression. Okay, and just double check I'm using double quotes on the outside. All of my quotes on the inside are single, 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 right? But in here, in this string, I want to swap that for 0, so that when it creates this link, it assesses the parameter name, and when it's looking at the parameter called scale, it will swap this for an actual static string called scale. But we'll do that with every node. So format p.name. Okay, and then close the set expression function. Okay, but hang on, we're missing one argument over here, which is going to be the language, and that's because by default it's H script. We need to specify, so we're just going to say language equals, and that's expr language dot Python. Okay. So let's test this. Again, I'm going to save just in case. And now because mode is 0, it's going to try and run this. Okay, so when we click apply, it creates a reference copy. Oh, hang on. And something has name expr language is not defined. Oh, sorry. It's my bad. It's who.expr language. Okay, so remember it's part of the Houdini module, so we have to include that. Okay, so let's delete that. Click apply. Okay, no errors this time. And when we click on here, we see everything is linked correctly. Our group linked correctly, even though we didn't specify that it's a string, because Python can convert that. And when it evaluates, it knows it's a string, so it just pops it in perfectly fine. Everything else still working fine. We can expand our folders, and our scene didn't crash. So this is perfectly fine. Right, so basically we have our whole script is working perfectly fine, except for the fact that we want to swap it for this for a loop. Okay, so n, instead of being equal to that, we're going to say for n in who.selected nodes. We then run that expression and then include all of this. So we're going to tab this in by 1 so that it's inside of this block. And so yeah, when we have When we have nothing selected, nothing will happen. When we have transform selected, it's going to create a reference copy. If we have grid selected, it's going to create a reference copy of the grid. Okay, so that works perfectly fine. Everything seems to be in order. And the only different thing that we want to do here is swap our mode for control click or not. Now that is not a possible thing inside of our Python source editor. We're not able to, because here we're just clicking apply, and when you click this button it's not aware of whether you clicked control or not. But in our remember I showed you in our shelf tools we have that quargs dictionary, and one of the things in there is control click. So we just refer to that by going to refer to the dictionary which is called quargs, and in that dictionary, to refer to a value, you feed it the key. So the key is control click, like that, and then that will just return a value which is a 0 or 1 depending on whether it was clicked or not. So 0 is it was not control clicked, and so that means when we don't control click it, it's going to do the Python one. But if mode is true, so mode is 1, so control click was clicked, then mode will be 1, so then it'll run hscript. Okay, so this won't work now if I click apply, because it's going to complain saying I don't know what quargs is, right? In fact, we can see that if I click it here, right? Oh well, if I have a node selected and click apply, then it's going to say name quargs is not defined. I don't know what this dictionary is, but our shelf script will. Okay, and so we can select all of this and then just create a new shelf tool. So we can say new tool. Remember over here we're going to actually copy it from the shelf, so I'm saving this into my Rebelway shelf, so I'm going to paste that in there, and then in our script over here we just copy this entire script, paste it in. So that should work perfectly fine. We obviously give it a name here. So I've already got one called ref copy, so I'm just going to leave mine, but please name yours properly. Call it ref copy and then reference copy or something like that, so it's nice and usable. You can also go and select an icon if you want, right? And maybe insert some help, so write a bit about what this does. Okay, and now when we accept, don't forget to clean up this Python source editor. For now, I'm just going to disable all of it, but you really should go and delete this once you're done, because if we close it, it's stored in our hip file. Okay, so you do not want that code executing every time you load your hip file. So we've got our new tool. Yours should be called reference copy, like mine over here. Select transform, click it. Should create a copy with a Python reference. And then if I control click, it should create a new copy with an hscript reference. Okay, and there we are. That's basically it. So yeah, I hope you guys had fun building this. It's actually quite a useful tool. I use it at work all the time. So because you want to create a copy but be able to dynamically link it. I mean, here you could even use an expression now, so based on some sort of switch or some other value, you could swap between which transform you're grabbing. So I hope you enjoyed it. I hope you learned a lot, and I hope you find this tool very useful. All right, so I'll see you all in the next lesson.